Hello, everyone. We are broadcasting to you live from the Schaumburg Solution Center in Schaumburg, Illinois. Today is November 11th, and on behalf of Amada, we'd like to thank you for spending time with us today. Welcome to Amada's Laser Technology Webinar featuring Amada's Brevis Fiber Laser. You're looking at a live drone view of the SSC verification floor making its way where we're broadcasting to you from live. Again, good afternoon, everyone. My name is Scott Bowerman, SSC General Manager. I got Dustin Deal. He's Amada's Laser Product Manager. We'd like to welcome all of our in-person viewers watching from any of our 3 U.S. technical centers, as well as everyone watching virtually. Before we get started, I'd like to wish everyone a happy Veterans Day. We'd like to thank all the veterans and those who serve in our National Armed Forces for their service and commitment. With gratitude, we'd like to salute you guys, for those who volunteer in time to protect our freedoms and a way of life that we enjoy here in the United States. So thank you very much. Today we have a brief 15 to 20-minute demonstration highlighting the technology available on Amada's new compact but productive laser machine. Although this laser machine has a small footprint, it's loaded with some great productivity-enhancing features. For example, the Eye Camera Assist System, or ICAS, makes part placement and nesting simple. The AMC's 3-eye control itself is extremely user-friendly, and operators love to use it because it's like touching an iPad. Anyway, if you have any questions to the lower right, please enter those in the chat box, and we'll be asking those to Dustin as we go through the demonstration. So let's go ahead and kick this off. I'm going to pass it over to you, Dustin.
Thanks, Scott. So the first thing we want to do is kind of come closer and take a look at this machine. First thing you're going to notice is a small, compact footprint. The entire footprint of this machine is about 10 foot by 12 foot. And this machine was designed and engineered based on some of the requests that our customers had. We had customers that were looking for an affordable R&D and prototype machine. So the need for a full 5x10 machine wasn't necessary. We also have customers that had limited floor space and they wanted to, something that was a high volume production machine as well. So with this machine, we're going to talk about several different aspects and the value that this machine has with the production mode, some of the Z-axis features that we have, and then the R&D and prototype aspect. So what we're going to do is I'll show you some of the features and the flexibility of this machine. We're going to go ahead and open this up, and then Paul's going to give us a demonstration. So the first thing you're going to notice is we have full access to the workpiece. If I had a light piece of sheet metal, I could go ahead and just drop it up on the table here. But what Paul's going to demonstrate is a couple other features of the machine. Let's take, for instance, if this was a heavy piece of plate, maybe this was half-inch material. Paul's going to show you how he could safely and ergonomically transfer this onto the cutting pallet. You see right here we have the ball transfer system that he engaged. It's going to allow him to easily slide the workpiece into the pneumatic clamps. Pneumatic clamps are also standard on this machine. He's going to orient his part, the X-gauge block located here at 0, 0, and he's going to slide the tray back in. But you'll also notice that we have a little bit of additional space. So if you needed to, you could load a full 4x8 sheet of material into this machine. That's going to allow you to do a couple things. You're not going to have a secondary operation such as a shearing process. You're not going to have to special order those 4x4 blanks. Go ahead and take advantage of that 4x8 inventory you already have. Drop it on the table here, and then you'll be able to make a shear cut and run that in 2 halves. So we're going to go ahead and tighten the machine up here. And we're going to be running some 18-gauge stainless. Also, a feature that I'd like to talk about is it's hard to see, so we're not going to show it up inside there, but there's actually the ICAS system that Scott mentioned. The camera's inside the machine. That's going to allow Paul to take a snapshot of his workpiece and be able to program that in that R&D and prototype environment. He's going to take advantage of it that way. The way we might be doing it now is just conventional programming. We're downloading our programs off the network that we're offline programming, and we're in a production mode. So while this part's running, I want to talk about kind of a third feature that makes this machine very unique, and that is the high Z-axis stroke that we have available. So in the event that you needed to cut some tight geometry on some already preformed parts, if you don't want to incur any of those bend distortions where you have geometry really tight against a bend line, what you can do is go ahead and form your part With the high Z-axis stroke, you can go ahead and load this tall blank in there and then go ahead and put in those fine details. Another thing you can do with it being a 3 kilowatt fiber, it expands the material processing range to include copper, brass, titanium. We also have some nice displays here that just kind of show some different methods of manufacturing, some of the tight part tolerances and quality that you can expect from this machine. We've got some product sample here of some nice 1/4 inch aluminum stainless mild steel, beautiful edge quality on the 1/2 inch here. The 1/2 inch also has some nice fine detail with some etching, but again, just kind of an overall variety of what the machine's capable of doing.
Dustin, there are a lot of common questions that people have on this machine. So I'd like to go ahead and ask a few of those, and I'll also work in some live questions as well.
Okay, thank you.
So what is all included with the purchase of this laser?
Okay, like any Amada product or any Amada laser, this is a full turnkey package. You'll see the dust collector located behind me, dust collector, chiller. You're going to have your assist gas air lines, hoses, regulators. It's going to come with training at an Amada school. We're also going to follow that up with an on-site training at your facility. So just like any Amada product, when it has the Amada name on it, it's going to be fully supported. So yes, it is a turnkey package, Scott.
Also, another question that's very common, what are the advantages of the iCamera assist system that you were talking about earlier?
Okay, we'll go over to the control, and I'll kind of hand it over to Paul, and he can go into some of the details of the iCast and some other nesting features that it has, but I'm going to go ahead and hand it off to Paul for that question.
Sure. So with the 3i control, there's a lot of user-friendly features for nest editing, program editing, or nest creation at the controller. In combination with the iCast system, it really aids the operator to quickly adapt to production change environment. And some common things that happen is that a hole may be out of tolerance or didn't pass QC or a customer made a quick change. So the operator can quickly go in, isolate his geometry that he needs to adjust. He can select them, adjust the cutting condition, and he can adjust offsets, cutting parameters independently from the rest of the program. Now in this case, he probably would have to make a few extra parts, so he can simply make additional parts at the controller. Let's just say he needs about 10 more parts. With the iCast system, he can take a snapshot of the cutting table and position his program on the remnant or sheet. So clearly it doesn't fit. He can make a quick adjustment and fit it on a sheet easily. And since it's a very visual representation of his workpiece, he can quickly notice that he can add additional parts. So the operator can merge other programs. He can place them on a sheet. He can rotate them. And in a matter of 1 minute, he can create a simple program at the machine.
Thanks, Paul. You know what? We're over here at the control. I'd like to talk about some other nice features of the 3i control. If you notice, Paul had full access to this control. He was able to edit programs, edit cut conditions. He could do all of that right here on the fly. But let's take, for example, maybe there's a lesser skilled operator. Maybe you're just in that production environment where you just want to run, constant 4x4 sheets of material. But maybe with a lesser skilled operator, what they can do with the user-defined levels on the 3i control, you can actually log in with 4 different user IDs. So user level 1, they're simply going to be able to just load a program and hit start. That's all we want them to do. As they gain more experience and their skill level increases, we can take that clear to a level 4 like what Paul has. Paul's a shop floor manager, so we give him full access to this control to make edits to the programs, to make changes to the cut conditions, view alarm history. That's another thing that's nice of this control is the alarm history on it. And what that's going to do is it's going to monitor a couple different things that we're looking for the performance of our machine. The first thing we want to see is how much is this machine running. We're looking for a high green light on time. So we're looking for a lot of green on our pie chart here. But we're also going to monitor, a total of 4 different categories. Here in a demonstration environment, there's a lot of standby time. That's what you're going to see here in the yellow. Another thing that we're going to look for is planning. That means Paul's over here at the control. He's loading programs. He's making edits. He's doing his job. And then the fourth thing that we'll monitor is alarm status. You know, there might be a little red sliver here of the alarm, the red, and we want to find out, well, what caused that alarm? Well, with the alarm history, we can go ahead and click on that. We can drill down into the exact time of the alarm and what it was. Well, it says it was a head collision. Let's look into that head collision a little bit more and find out what that was. You know, maybe it was some internal geometry that wasn't tabbed. Maybe it was a part that wasn't tabbed. And we need to take that back to the programming level and say, hey, let's add a better tab or something like that so that we have more valuable green light on time. Another nice piece about this type of data is that we can export it into our Amada Influence software. Our Influence software is a very powerful shop floor management tool to where, at a glance, whether it be this laser, press brake, combination machine, turret punch, all this can be easily exported into our Influence software and then managed at a shop floor management level at a glance. You know, with a dashboard, you can check the status of all your machines and make sure you're getting the most green light time possible.
So I think that the control itself, it's a very powerful control and very user-friendly. I think we've just scratched the surface. We won't go through the complete control. Right. Dustin, a minute ago, you were showing on the parts table that box and the ability to cut holes on the top of an enclosure. Someone had asked the question, what's the maximum Z height that you can cut?
7.93 inches, almost 8 inches.
Okay, very good. Let's go ahead and I got another question here. What style of cutting head is used on the laser?
Okay, I'll go ahead and have Paul bring the cutting head to the front of the machine. Simple utility, he's going to touch it, bring it right here to the door. And the first thing you're going to notice is how easily Paul can access this cutting head. We use a cartridge style cutting head. There's a lot of terms in the industry. Maybe you've heard the term like a sealed head. Well, we use a cartridge style, and you're going to see why we do. With just a matter of a few seconds, Paul has full access to that lens. He can inspect it, he can clean it, he can replace it. There's also a protective window glass in there to protect it against contamination or splatter. He can change that out in just a matter of seconds. Also, the advantage of this cartridge style versus a entire sealed head is in the event of a collision, you know, you might wipe out the nozzle, then maybe the nozzle plug. Worst case, you damage the cone. Our machines come with an additional cone, so again, just in a matter of minutes, Paul can replace any of those consumables and be back up and running. In the environment of a sealed head, that may make a phone call to a factory-trained technician. You may be waiting a couple days to get them on site. Paul's back up and running in just a matter of minutes with the cartridge-style head.
So, Paul, while you do have that open, I actually have a good question. Someone asked, is it possible to remove the slats to put a fixture inside there?
Yes, and we can easily demonstrate that.
So actually, they are basically snap in place. You can pull one out. You can cut your own patterns. You can actually even cut them almost to fixture tubing or larger fixtures, so you can get even a little bit more height ability for the laser, and really easy to replace.
And also by removing those, you could actually fixture down within the depth of the table for even more additional Z height if needed.
Okay, great. Also another question, can you process an entire 4x8 sheet?
Well, you can load an entire 4x8 sheet. What we do is what we call like a shear run. So I'll just open it up again real quick, and you'll see that we have additional space here underneath the Z-axis here. So here's where we can load the full 4x8 sheet, again, taking advantage of that factory inventory and not having to order special cut-down blanks. But what we do is we would run our program, pull up the utility in the control, do a shear cut, remove our parts, slide our second half back down into the clamps, hit start, and run it again. So that's probably what you would do in a production environment, is just run, shear, run, and that's how you would be in production versus maybe the R&D where you just have some scrap up here and we're just using the ICAST system. So you can hold a whole 4x8, but you only process up to a 50-inch by 50-inch part at one time.
I think you may have covered this already at the beginning, but someone's asking, what is the actual size of the laser footprint?
Yes, the overall size is 10 foot by 12 foot. It's It's all encompassed in one small footprint. You can see right here on this cabinet, oh, we're going to get a good drone shot above here. So you can see right here in the cabinet is our 3 kilowatt engine, all of our power supplies, our circuit boards, our drives, everything's right in here, mounted on the frame. So that's what gives us that ability to load that 4x8 sheet. But again, 10 foot by 12 foot.
Okay, and I will ask one more question here. What is the maximum material thickness that you can cut on this laser?
It's going to be 1/2-inch stainless, aluminum, and mild steel with the cutting lens that we have in it. To take it to the absolute max material thickness, that'd be 3/4 inch mild steel, and for that we would just do a simple lens exchange. But 1/2 inch across the board, and then with a lens change, 3/4 mild steel.
Okay, very good. Someone was asking a ballpark price for this machine. I don't know if we can throw that out there or not.
We're in the low 300s. Very, very price competitive, I think, for the market.
Okay, very good. I think we have all the questions answered, and I don't know if you have any more questions, but I think we're good. I'm kind of keep it short and sweet. So we will have this machine here for several more weeks. So it is on the SSC floor. So if you would like a virtual demo, in-person demo, we want us to run some parts, some time studies for you. Please let us know. Please contact your machine sales engineer, and we will do whatever we can to help you out. So anyway, we'll keep it short today. Thank you very much for attending, everyone. Thank you, Dustin. Thank you, Paul. Thank you, group.
Thank you, everyone, for your time.
Everybody have a great day.